Hello and welcome back to Data and AI Summit 2021. I hope you've enjoyed all of yesterday's content and sessions and that you're ready for another full day. We've got a lot for you today, but first, a few quick reminders. First, get social. As we go today, be sure to use hashtag DataAISummit and share your thoughts and feedback with the rest of the community. Also, check out the Data AI Summit social channels for the latest summit news and activities. Second, please find some time to visit our sponsors in the Dev Hub and Expo. Lots of cool demos and prizes and different ways to engage with them. Third, if you feel inspired to do so, please donate to any of the 3 causes that we're sponsoring here at the summit this year. As a reminder, Databricks is matching all donations up to $50,000, which means that together we can give up to $100,000. We've made good progress yesterday, but still have a long way to go, so I hope you can all take time and learn more about these organizations and donate. Yesterday, we talked about our theme, our shared belief that the future is open. And we talked about how this community is at the heart of the open source revolution of data and AI. Today, the projects that you see here get over 30 million downloads every month. These technologies are essential to building lakehouses, which leverage open source, open formats, and open standards to unify data types, tools, and workloads. In yesterday's talks, we focused heavily on that middle layer of the lakehouse, Delta Lake, which brings data management and governance to enable any downstream use case on top of your existing data lake. Today, we're going to focus a lot more on the bottom and top layers, starting with Apache Spark. Spark has always been at the heart and soul of this conference, and the community we built together around this remains critical to the open future we're talking about here today. The community remains super vibrant and passionate, and there's a lot of super exciting innovation happening around Apache Spark. To talk about it, I'm excited to pass it over to the all-time contributor to Apache Spark, Captain Reynold Chin.
Thanks, Ali. Good morning, good afternoon, and good evening. I hope you've enjoyed Data and AI Summit thus far. This conference started as a Spark Summit, and these roots are very important to me personally and the Apache Spark community, even though we've expanded to cover a lot of other topics and technologies. I want to talk to you today about the growth of Spark, its shift in usage, and in particular, making Apache Spark better for data scientists. Today, we're seeing more and more Spark's used as the engine to power the Lakehouse architecture. And this is about combining the very different types of workloads and use cases, from ETL to BI to data science to machine learning. But this was not always the case. In 2013, virtually everybody was using Spark Scala API. Over the years, we've done a lot of work to make Spark more accessible to data teams, including improving the SQL and the Python API. Last week, we looked at the number of commands run on Databricks Platform, and it's astonishing when comparing with 2013. While Scala is for sure still a first-class API and powers many of the most important compute-intensive data engineering jobs, you see the rapid rise of Python and SQL, each claiming almost half of all of the commands. And this is really the evidence for the Lakehouse vision, because data scientists are using Python, while a lot of analysts are using SQL. The development of the Spark project also reflects this trend. We're investing heavily in SQL, in particular when it comes to NC SQL compliance. And Python, I don't have a lot of time to go into details about all of the changes, and we have to spend sort of hours and hours here. But instead today, I want to focus on data science and Python. So most data science workloads are done on laptops today, and the dominant programming language is Python. Due to resource constraints on these laptops and sometimes just beefier servers even, the way the libraries are designed, they can usually only handle hundreds of megabytes of data, and occasionally going up to gigabytes. So data scientists often work with a downsampled data set instead of the entire data set. Now, of course, some data scientists also use Spark to process terabytes or even petabytes of data. However, Spark's a very different tool from what most data scientists know, and the gap between laptop data science and distributed computation can be very large. 2 years ago, we came up with this idea of how do we marry the both worlds? The single node Python data science world with distributed computation on big data. We want to really make it easy for data scientists accustomed to programming on a single node, like a laptop, to work in a distributed Spark environment. And as all of you are probably aware, the most important library, the single most important library for data science is Pandas. If you pick a data science 101 class, chances are it would teach you pandas. So we came up with the idea to scale pandas API using Spark and created the experimental library called Koalas. Koalas were announced about 2 years ago. Enables data scientists to easily port their pandas codebase over. With one line of import change, their pandas code can now execute at scale. There's no need to learn a new API. You can even just search on Stack Overflow and find snippets of code others have shared and use those to cover a much larger amount of data. In the past 2 years, we've been really humbled by the reception and adoption of Koalas. Every day now, we see 3 million downloads of Koalas on PyPy, the Python package index. And many of our customers have told us Koalas fundamentally changed the way they work. Just like data engineers used to tell us about Spark that changed the way they conduct data pipelines, data scientists tell us now Koalas have changed the way they do data science at scale. Today, we're super excited to announce that Databricks donating the Koalas project into upstream Apache Spark. We'll work with the rest of the community to merge Koalas in. Now, anytime you write code for Spark, you know that the pandas API is available at your disposal. There are 2 big advantages of running your pandas code using Spark: scalability and performance. Even on a single node, for larger amount of data, like one shown on the screen that was 31 GB, pandas on Spark can perform better than pandas itself due to the multi-threaded execution, because pandas runs everything in a single thread. Sometimes pandas perform better because it's a lower overhead. But once you get to larger amount of data, pandas wouldn't be able to handle it. Often you get an out-of-memory error, or if it could, it might be slow due to the single-threaded nature. Pandas on Spark, on the other hand, can leverage Spark's own computation engine to handle large data sets. Even on a single node, it can gracefully handle data much larger than memory using external operations. And of course, if you add more compute resources to it, it can scale linearly to reduce runtime, all using the same pandas API. One other thing that's really cool about merging Koalas into a Spark is that Spark users now, even without using the pandas API, can get visualization capabilities out of the box. With just a few lines of code, they can plot beautiful charts for their data big and small. And the best part is users don't even have to downsample their data. The pandas API on Spark has implemented efficient plotting techniques based on the types of plot you're using. If you're plotting a histogram, KD, or box plot, you compute the data to plot using PySpark API under the hood, such as bucketizer, kernel density, and approximate percentile. It then passes the result to a plotting library, such as Plotly, to draw the plots. You can finally plot your entire dataset without needing to downsample it first and risk an out-of-memory error. Now, plots such as pie chart, bar chart, or bar H and scatter plots are implemented by taking the top-end records. The pandas API on Spark selects the top end by limit and head and passes the result to the plotting library. If you're plotting an area chart or line chart, it runs a uniform sample across all of the data and draws the plot using the plotting library. So now Spark, once Koalas merge into Spark, Spark will expose many different APIs for different use cases or personas. And what's really cool is all of them leverage the same underlying engine, will go through the same optimization pipelines. So you get more or less the same performance, regardless of which one you want to use. We hope you all find the adoption of the pandas API to Spark makes your move to big data Python data science simple. In the second half of the talk, I want to talk to you about the general area of work to make Spark more Pythonic as part of Project Zen. Project Zen's named after a set of 20 guiding principles in the Zen of Python by Tim Peters, introduced in 2004. Clarity is very important for a great developer experience, so here are the 4 principles which guide us to increase clarity. First is error should never pass silently. Readability counts. Explicit is better than implicit, and simple is better than complex. You have used PySpark. You probably noticed PySpark's error messages are not the easiest to read. As a matter of fact, there's a tweet by Randy here in 2015 that pointed out, hey, 30 characters of code can use 97 lines of error messages. And we have heard you, Randy. Back when some of those tweets were written, we had pages upon pages of error messages, intermixing typically Python stack traces and Java stack traces. We started improving error messaging in Spark 3.1, making the origin of the Python error much more clear. And in the Data and AI Summit in 2020, we talked about actually cutting down 6 pages of error messages down to just 1 in Spark 3.1. But we didn't stop there. Now we have actually made this error messages even shorter by another 50%. And this change is in development, will be available in the next release of Spark. Now, being concise isn't the only goal. Another important part of error messages design is to make it easy for users to find the underlying courses. The typical workflow for most data scientists or engineers is search on the web or Stack Overflow to find what's going on with their program. And to make that specific workflow easy, we're introducing error codes to error messages. This will make it much easier to locate and capture the root cause of errors. And this change will also be available in the next release of Spark. While runtime errors are helpful, it would be even better if we can catch error and mistakes at the time of writing code. So we've introduced type hints throughout Spark's codebase that will result in much better error messages in both IDEs and notebooks using static analysis, as shown on the screen here. In addition, type hints also act as the explicit contract for large codebases, and this change will be available as part of Spark 3.1. Now, let's move on to autocomplete. I personally rely on autocomplete in IDEs and notebooks every day because I can't memorize all the different APIs. Before Project Zen, autocomplete for PySpark leaves a lot to be desired. It lacks context and can't show the most important things. In the screen here, I most likely wanted to look at the various different types of CSV parsing options, but the suggestions are not at all useful. Now with Project Zen, we're shipping a much better autocomplete that's context-aware and relevant, and it works both in IDEs as well as notebooks. All of this great Python code you're writing often require dependent libraries to be installed or configured. And this is uniquely challenging in a distributed environment where some of the nodes that can have library available while some of the others don't. We've now actually improved our integration with Conda, virtualenv, and PEX to ship and manage Python dependencies. So you can manage all of these dependencies of your program on a cluster using the same set of tools on a single node. Now I'm going to pass it over to Brooke Wennick, a data scientist at Databricks who uses pandas every day. She's going to show us a demo of some of these new changes working together.
Thanks, Reynold. This past year, Hawaii has become an even more popular vacation destination. And for this demo, I thought it'd be fun to analyze some Airbnb listings for Hawaii so that we can plan our vacation too. Plus, who doesn't love pandas on a surfboard? I started my foray into data science with pandas. I loved the ease of the API, the documentation, the developer community, everything about it I love. As you can see, I've already written some pandas code here. I'm going to load in a dataset, filter out some records that the price is either free or above $10,000, because yes, those show up in the dataset, and then select just a subset of the columns. Now, let's go ahead and take a look at our data. We can see here the number of bedrooms, the listing, the name, etc. But now I want a solution that scales. Maybe not just for Hawaii, but for all Airbnbs across the globe. To do that, all I need to change is just one import. Instead of importing pandas, I'll import pyspark.pandas, and I'll change the alias as well. So now we have a solution that scales without requiring any code change apart from an import. And as you can see here, we get the same results. So by merging this pandas API on Spark into the core Apache Spark project, Spark finally has a solution for plotting data at scale. I no longer need to downsample my data or collect it back to the driver. Based off of the type of plot that I'm using, the pandas API on Spark will figure out the optimal way to execute it. So now let's go ahead and take a look at the average price based off of the number of bedrooms. You can see here that the default backend is Plotly, a visualization tool many of you already know and love. And we can see that as the number of bedrooms increases, the price also generally increases. But there is a steal of an Airbnb with 11 bedrooms for $900. But you're not locked into just using the Panda syntax. We can always call toSpark on our data frame and get the underlying PySpark data frame. This effectively drops all of the metadata, and so you can see there's no performance hit to going back to our underlying PySpark data frame. So now we can always use the PySpark API to ask questions such as, what is the most popular property type that is available for rent? And we can see the top three are condos, houses, and apartments. If we were to do that using the Panda syntax, you'll actually see it's quite different. The end result is the same, but the syntax is quite different. And this is what the Pandas API in Spark seeks to unify. One API that scales as your data scales, so you don't need to spend time converting it over into another syntax or accidentally introduce errors in the process. And lastly, the moment you've all been waiting for. Which Airbnb should we rent? While I could write this code in Python to answer that question, I actually find it a little bit more intuitive to write it in SQL. Here you'll notice I'm using ps.sql, quite similar to spark.sql, but it has an added benefit. Whenever I work with the Pandas API on Spark data frame, it's automatically registered inside of the SQL context. What that means is that I no longer have to create a view or a table to be able to then query it in SQL. I can just natively access it by passing it inside of these curly braces. So I'm going to go ahead and select all of the columns, but I'm going to filter for just looking into the neighborhood of Lanai. I'd like the host to be a superhost, the price to be less than $400, and it must be sparkling clean. So it looks like we're recommended to stay at the artist house. I don't know about you, but I'm interested in taking a look at some photos of this. Let's go ahead and pull up the listing URL. So here we can see the artist house accommodates 6 guests, 2 bedrooms. Overall seems like a great place to stay. Mahalo. Thank you, everyone. And now I'd like to pass it back to Reynold. But before I do that, I think you need your very own surfing panda, Reynold. Surf's up.
Thank you, Brooke, for the demo and of course the surfing panda from Hawaii. Just to wrap up, the core focus of Spark project today is to enable the Lakehouse architecture, creating a single platform for data engineering, SQL, BI, data science, and machine learning. In this talk, we focus on 2 parts. The first is the merging of the Koalas project into Spark, so data scientists can now be using a single Pandas API to perform analysis on both data small and large, on a laptop, and large data on a cluster. In addition, we have done a lot of work on the usability to make Spark a lot more Pythonic, with dramatically shorter and more clear error messages, contextual autocomplete, and type hints. These changes really marry single node data science and big data, making Spark an even better tool for data scientists. But in reality, there are a lot of exciting changes everywhere that we didn't have time to get into today. Please keep an eye out for them in this conference or other talks in the future, and the blog posts and release notes. Thank you very much. I'd like to pass you back to you, Ali.
Thank you, Reynold and Brooke. I'm really excited about the great work of Project Zen, as well as the integration of Koalas into Spark. It's going to make it a lot easier to execute data science at scale. When it comes to data science, one of the biggest areas of interest today is machine learning. The MLFlow project has had a huge impact on this, becoming the most widely adopted open source machine learning platform in the world. Here to tell us more about how this project has evolved is Matej Zaharia, Chief Technologist at Databricks.
All right, I'm really excited to give an update on MLFlow, the open machine learning platform that we launched as an open source project at this conference actually 3 years ago. So in 2011, Mark Andreessen said that software is eating the world. He was observing that in more and more industries, software had become essential to performing well in that industry. It was one of the key differentiating factors between companies and products and so on. Most recently, a lot of folks have been saying that AI is actually eating software. And the reason for that is that AI has actually started to play really important roles in large classes of software, or even to replace previous systems that involved a lot of custom business logic and do quite a bit better with it. So just as some examples of that, recently OpenAI used GPT-3, a variant of GPT-3, to just generate images from text. You can just imagine, some of the applications of this for something commercial. Google has been using AI for medical diagnosis, for example, measuring hemoglobin levels in a patient just from retina scans without an invasive procedure. And OpenAI has been basically revolutionizing the way that we can train robots to perform various tasks, so that instead of fine-grained rules you specify for how the robot will move, it can actually just learn how to do specific tasks efficiently. So AI has obviously impacted all aspects of business, but today it's only done that for a select few companies, the Facebooks, Googles, Netflixes, and Ubers of the world who can run these massive engineering and development programs and build these kinds of applications. So the natural question is, what about the rest of us? So interestingly, when you look at these massive tech companies that are successfully using AI today, one of the reasons they're successful is because they've done massive investments in the underlying platforms. It's actually not so much the algorithmic insights that they have in there. Someone comes up with a new algorithm. It's actually the infrastructure to actually take these algorithms and turn them into a reliable product that you can actually launch and that can do important business decisions for your company in real time. And so all of these companies have built what are called machine learning platforms, infrastructure that allows their engineers and data scientists to build, maintain, and operate machine learning applications all the way from data to production. And they have teams of hundreds of people working on just this infrastructure, which then allows other product teams to build these hundreds or maybe thousands of internal ML applications that these businesses have. So just as some examples, in Google, Google open source TensorFlow, but they have a whole platform called TensorFlow Extended, TFX, that teams use internally to develop applications. Uber has a platform called Michelangelo that supports hundreds of applications. Facebook has FB Learner, and so on. So these are kind of the engines that power actually productionizing machine learning and having hundreds of use cases on it. So when we started looking at this domain at Databricks 3 years ago, we started these companies were building them. Every company's ML platform was very customized and internal and bespoke for their architecture. And we thought that there has to be a better way. And so we asked, can we design an open ML platform where actually a wide range of organizations can contribute on this and make it shared infrastructure as opposed to something you have to build yourself. And that's what we did with MLFlow, the open source machine learning platform. So MLFlow is an open source project at the Linux Foundation, and it provides 4 key capabilities that you need to productionize machine learning. It's got components for tracking or monitoring how your application is doing over time, for reproducible runs of your application, for packaging and deploying models, and also for reviewing and centrally sharing models through the model registry component. And these components are designed so that all of the users involved at different aspects of the machine learning lifecycle can easily collaborate on these applications, make sure they're working correctly, and troubleshoot any problems that come out. But MLFlow is also open in another really critical way, which is that it's designed to have an open interface, so you can easily plug it into your favorite machine learning systems, even internal systems you have, or into your favorite vendor products that live alongside that lifecycle. So it can be used in any programming language, and it can be used in any machine learning library. And it also connects automatically to many popular commercial services to allow you to switch between them when you deploy your application and easily use best-in-breed tools to manage your applications. So if you're not familiar with MLFlow, I'll just highlight a few of the things it can do. The first way most users begin using it is through the tracking component, which allows you to track experiments while you're developing your model and then track production runs of it once you finish developing it to make sure that it continues doing well over time. So in a lot of machine learning libraries today, the community has created connectors to make tracking in MLFlow super easy. So for example, here I'm showing some code to train a model in Keras. If you want to start instrumenting that process with MLFlow and keep track of all the information in real time, you just need to call the MLFlow Keras autolog function, and that will actually automatically instrument Keras and capture all the relevant information about the model that you're training. And so that will give you in MLFlow this nice graphical interface where you can see all the times you've trained the model before. You can compare it over time. You can experiment with different parameters. And you can also see which versions of your code were used. And so you can immediately start structuring your development process and making it much easier to troubleshoot issues. Now, that's just experiment tracking, another key aspect of MLFlow is the model registry. This is a collaborative environment, a little bit like GitHub, where you can register all your models and keep track of multiple versions of them, and move your models through a software development lifecycle where they can pass through stages such as testing and production, and different users or automated systems can approve changes to them before you, before you actually deploy them. So this is another key element of the platform that actually lets you centrally manage these models and make sure the right one is used in each application, the same way you would centrally manage different versions of software. Finally, MLFlow has a lot of built-in connectors from the community to different ways of deploying the model. So one of the really powerful features is whatever library you use to develop the model, once you put it in the registry, it's in the standard packaging format that we call MLFlow model format. And then there are actually all these tools where you can easily deploy the same model without having to know how it was trained, what software version, what libraries, and so on. So for example, you can take the model and put it into any of a number of open source or commercial online serving tools. You can do batch inference on massive data sets using Apache Spark. You can just load the model into code and call into it there, or you can push it to edge devices. And so you get this whole ecosystem where you don't have to write something special to get your model into these different deployment modes. So we're very excited with the continued momentum of the project. The community has grown a huge amount. You can just see in this plot here over the past year, we've grown to over 5 million monthly downloads of MLFlow on PyPy and over 300 contributors to the project just in the past 3 years since we launched the project. And on Databricks, with the hosted version we provide, we've seen tremendous growth as well. Today, we have thousands of customers using MLFlow on the platform, and they're creating more than 1.5 million experiment runs per week that are producing new models that then they work with. So a huge amount of production machine learning happening just through this platform. So what's new in MLFlow over the past year? There's been a lot of activity in the community, and I just wanted to highlight some of the new things. One of the big efforts over the past year has been to make it easier to integrate MLFlow into an existing application. And we've done that by adding auto-logging packages for a lot of popular libraries, like I showed before with Keras. We're actually making this even easier now by adding a single MLFlow.autolog API, which automatically detects which ML libraries you're using and enables logging for all of those. So it'll be very straightforward. If you have an existing piece of code, you can just add this one line in there and start capturing detailed information about the training data and the code and the parameters that you used, and of course, the models themselves, and begin operating on that information. We've also added a whole bunch of new features to tracking. One of these is built-in support for model interpretability using the popular SHAP library. So you can now log explanations of your model and get these graphics that explain exactly why the model is making specific predictions. And obviously, this is super useful when you're reviewing your model before you decide whether to deploy a new version to quickly understand why it's making predictions and what's different from the previous one. You can also log arbitrary objects now, like figures and text files and images and so on, so you can customize the information that you're logging in MLFlow. We also have an MLFlow thin client package that has much fewer runtime dependencies that you can use if you want a lightweight way to explore the data you have in MLFlow from an application without pulling in all of its dependencies. So these all make it easier to work with it. And then on the deployment side, we've also got a lot of activity on deployment backends. There were quite a few supported in the project already. And in the past year, we've also added Ray, Algorithmia, and PyTorch TorchServe as ways you can deploy your models on there. So once you save a model, you have a huge variety of options for how to use it. And it's just one line of code, regardless of your model type, to get it into any of these serving systems. One thing I wanted to highlight in the community that I'm really excited about is the integration between MLFlow and Pycart. So MLFlow is actually now part of is a key part of the Pycart machine learning library. If you're not familiar with Pycart, it's a popular low-code machine learning library that you can use in Python. Basically, with just a few lines of code, you can load in some data, it can understand the features in the data, and it can try a variety of algorithms and give you what is now a deployable and manageable model using MLFlow. So it's a very popular library for just getting started with machine learning. And so the way it works in Pycart, this is basically a complete Pycart application that trains a model on some insurance data. And actually in this application, in case you haven't noticed, there's actually this code in here is what enables MLFlow. So if you're using Pycart, you call your setup function, you can just provide an experiment name in your MLFlow server, and it will automatically log all that information into MLFlow. You don't need to do anything else to get it. And so you can just run, you see it's very little code to actually experiment with lots of models in Pycart. And if you add these parameters in there, you automatically get this information in the MLFlow UI. And then you can manage your models there, share them with users, review them, and so on. There's actually a whole talk about this at the summit. I invite you to check it out if you want to see how to connect MLFlow to low-code, automated machine learning. Finally, we have quite a bit of exciting work on the roadmap ahead for MLFlow this year. And of course, we'd love to get your feedback as we develop these things in the open source Slack channel. So one thing that we're continuing to push on is the integration with the PyTorch ecosystem. PyTorch has a wide variety of really powerful tools for model explanation, interpretability, profiling, and so on. And these are two of the things we're working on today. So first of all, we're integrating with the Captum library, which is a model interpretability library powered by PyTorch, and we'll be integrating those visualizations directly into the MLFlow UI. If you haven't seen Captum, Captum makes it very easy to interpret the prediction of a wide range of models using the latest and greatest methods for that. So you can use it for computer vision to see what objects it's detecting. You can use it for text to explain the predictions of language models. You can, of course, just use it for simple models on numerical features as well. And you'll be able to take all these things, log them into MLFlow, and compare them across your experiments over time. We're also integrating with the PyTorch profiler for debugging the performance of your deep learning models. Another major area we're starting on is model evaluation. So you've logged all these models in MLFlow. Maybe you've deployed them. How do you now evaluate how they're doing? So there are two projects there. The first one is offline evaluation. Let's say you've logged a whole bunch of models, and you want to compare them, maybe on a specific slice of the data or a new test set you've collected. We're going to have APIs that makes it very easy to do that. And then the other one is online evaluation. When you deploy a model, we'll make it easy to also deploy code that actually outputs, captures and saves the predictions and the inputs that went into the model into a standard format like Delta Lake. So you can now get these streaming predictions and start evaluating the online predictions and see how they compared to the data that you trained the model on. A third thing that we're doing is integration with production job systems. So for example, in Databricks, we're integrating MLFlow tracking directly into the user interface for our job scheduler. So you can actually see the metrics and artifacts and so on produced by MLFlow directly there. And this is also something that we'd like to do with other job schedulers in the open source project. So this is sort of a sneak peek at how it will look. This is the jobs interface in Databricks. You can see, we've run this job a bunch of times in the past few days. And you can actually see the custom MLFlow metrics we have for this job directly in the interface. So I can quickly eyeball this and see whether my job, is starting to do poorly from an ML perspective, even if it actually successfully, completed and ran on time. And actually, we can see here, one time I actually had too many null records in the data, which is something I was able to just track. And this is, surfaced right here in the UI. So I could quickly see that and fix the model. And finally, the fourth thing that we're doing is more work on the open source MLFlow server to make it easy to customize it. So for example, we're working on a plugin API so you can have webhooks or custom logic every time an event happens in MLFlow, and so you can easily connect it into your organization's machine learning lifecycle. So there's an exciting roadmap ahead from MLFlow, and we'd love to get your feedback from it. The final thing I wanted to mention is that we also think we're getting close enough in terms of experience with the project to actually launch MLFlow 2.0. And this is a chance to actually improve a lot of the core APIs and data models and maybe add new capabilities. So we've launched a survey where we'd love to get your feedback on machine learning infrastructure in general, and in particular, what you'd like to see in MLFlow 2.0. So make sure you check that out, whether you're a current user or not. We'd love to hear what will make it easier for you to build an ML platform at your company and reliably deploy and maintain machine learning applications. So next up, I'm really excited to introduce Clemens Maywald, the head of product for data science and machine learning at Databricks, who'll talk to you about some of the new machine learning capabilities we've added to our platform, many of them that integrate tightly with MLFlow. Go ahead, Clemens. I'm passing the baton to you.
Well, thank you, Matej. Looks like you reeled in a big one. I'm very excited to talk about machine learning on Databricks today. As mentioned, just as software has transformed many businesses and created new ones, AI will do the same. By definition, AI has been able to achieve tasks that previously wouldn't have been possible by manually writing software. However, we all know that most of the time spent in developing AI is focused on data, and that without good quality data, AI just doesn't work. So what is really happening is that data is the bigger beast that is eating AI. And while that may just sound like a catchphrase, there's actually a lot of truth to it. Let's take a look at why the focus is really on data. The main reason is that we've become really good at dealing with code and data separately, but we are terrible at combining them. In software engineering, the main goal is functional correctness, and in most cases, you can write good tests to ensure that. AI, on the other hand, tries to optimize a metric, which can be a moving target with changing data. Measuring quality in software is also easier, because it deterministically depends on code. However, in addition to code, the quality of a machine learning model depends on the data, model architecture, hyperparameters, and in some cases, it can quite literally be random based on the random initialization of parameters. Finally, the outcome of software is deterministic, whereas in AI, the outcome of training a model can change significantly based on changes in the underlying data. All of these factors combined make it painfully clear that AI is hard because it depends neither on code nor on data alone, but on the combination of both. As a result, many different people need to get involved. I'm oversimplifying, of course, but software is mainly built by software engineers. To train a machine learning model and deploy it in production, on the other hand, you usually involve some combination of software engineers, data scientists, and data engineers. So getting all of these people involved and coordinating among them is a major challenge. Now, this is not uncommon, of course. Some of the most meaningful problems can only be solved by bringing many people together. However, it becomes almost impossible if those people cannot agree on the tools that they should use. In software development, usually a team standardizes on a stack, like which language, code versioning, or CI/CD system to use. And these tools have matured over time. In AI, I have seen many teams where different individuals prefer different machine learning frameworks, use different IDEs, and most certainly don't follow common CI/CD practices. In fact, this overview of the data and AI landscape by Matt Turk draws a perfect picture. Now, how you feel about this situation likely depends on who you are. If you are a VC or a researcher, you look at this landscape and you get excited. This is clearly a thriving ecosystem of innovation, with lots of opportunity for investments and PhD theses. However, if you're an enterprise architect who is responsible for making purchasing decisions, or a tech lead on a software engineering team, you probably think that this is a procurement and DevOps nightmare. You'll have to look at each one of these boxes and pick the right tool, and then spend lots of time and energy stitching them together. So the tooling is really hard because AI requires integrating many different components, and the space is moving at a breakneck pace. In summary, we are faced with three challenges. AI is hard because of the interdependency of code and data, many people needing to get involved, and a massive amount of components needing to be integrated. So what are the attributes of a solution? Well, first and foremost, since data is eating AI, the solution must be what we call data native. This is already where many machine learning platforms fail because they naively assume that the data problem is already taken care of. Secondly, data teams can really only be successful if they work together. So a solution better be collaborative and open to all members of a data team. And finally, the solution must integrate all components to satisfy the full machine learning lifecycle, and because the ecosystem moves at such a breakneck pace, it better follow open source standards. Many solutions out there fail to meet these requirements because they either disregard data engineering entirely, narrowly focus on only one persona within a data team, or they don't solve for the full machine learning lifecycle. Now, this would be a terrible keynote if I didn't have good news for you. If you know Databricks, you know that these attributes are at the core of what we do every day. And this has been a very long time coming. I'm extremely excited to announce the launch of a new product, Databricks Machine Learning. Databricks Machine Learning is a data-native and collaborative solution for the full machine learning lifecycle. It provides all of the capabilities needed for data teams to successfully train and deploy machine learning models and focus on their business needs as opposed to playing system integrators. So let's start with first things first. What do we mean by data native? As indicated on the bottom of this slide, Databricks Machine Learning is built on top of an open data lakehouse foundation. If you think about it, the first thing you should care about when picking a solution for machine learning is whether you can access any type of data at any scale from any source, which includes access to data across clouds. With Delta Lake, you can do just that. It doesn't matter whether you have images, video, tabular data, or whether those come in small files like CSVs or in terabytes of streaming data from IoT sensors. Delta Lake gives you consistent and high-performance access to all of your data. So what does this mean for machine learning specifically? When you train a model with the machine learning runtime, you benefit from optimized writes and reads to and from Delta, and because Delta provides ACID transaction guarantees, you can trust that your data are available at high quality and consistency. Delta also provides built-in data versioning through its time travel feature. Through an integration with MLFlow, we automatically track exactly which version of your data you used when you trained a specific model. That gives you full lineage from data to model and comes in handy when you think about reproducibility. So now that we've established what data native means, let's look at how the data science workspace makes Databricks machine learning collaborative. The data science workspace facilitates collaboration by supporting multi-language notebooks. You can use Scala, SQL, Python, or R, all within the same notebook. Now, the power of multi-language support really comes together once you collaborate with others. So the notebooks also provide cloud-native collaboration features like co-presence, co-editing, and commenting. And finally, and most importantly for machine learning, the workspace integrates tightly with MLFlow. Here you can see the experiment sidebar that shows tracked parameters, metrics, and models, right within the context of your work. And at the core of Databricks machine learning, of course, are all of the components that facilitate machine learning from data to deployment and back. We start with data prep. As mentioned earlier, Databricks machine learning, being a data-native solution that is built on a lakehouse, supports any type of data at any scale. Now, there's more to this story than just being able to process any kind of data. Later in this talk, I have a surprise announcement for you that addresses machine learning-specific needs for data prep. Once your data is in shape, you can train models using any machine learning library you want. We provide a runtime that is optimized for machine learning and packages up the most popular ML libraries, like scikit-learn or TensorFlow, as well as popular tools for distributed training, hyperparameter tuning, or model interpretability. For model deployment, we support any and all deployment modes from batch to online scoring on the platform of your choice. Of course, as you know, Databricks is multi-cloud, so you can also train your model on one cloud and deploy it on another, or even on-prem or on edge devices. Getting to the foundation of machine learning, what is often referred to as MLOps, we found that true MLOps is really a combination between data ops, DevOps, and model ops. And of course, on Databricks, we combine all of these aspects with data versioning using Delta Lake, code versioning using our own new repos feature, and model lifecycle management with the MLFlow model registry. But that's very abstract. Let's see what it looks like when you get MLOps right. And I like to explain this from right to left. Let's say you have a model deployed in production. You should be able to find out where it came from. The model registry shows you the entire history and approval workflow the model went through. From there, you may want to know the offline metrics and who trained the model. From the model registry, you can go back to the experiment that initially logged the model and find all of the metrics, parameters, and artifacts. And if that experiment was created on Databricks, we captured all of the environment information from your workspace as well. You can probably see where this is going. If you know the exact code that you used, the hardware configuration, library versions you installed, and the exact version of your data, we can give you a single button to reproduce the model. And we do just that. And this is really how you know that you've gotten MLOps right. So in summary, Databricks Machine Learning is a data-native and collaborative platform for the full machine learning lifecycle. But that's not all. As mentioned earlier, I have one or two surprise announcements for you. I'm extremely excited to announce a brand new addition to Databricks Machine Learning, a feature store. Our feature store is the first that was co-designed with a data and MLOps platform, and I'll walk you through what that means in a minute during the deep dive. And if that wasn't enough, we're also announcing today the release of our own native AutoML capability. Databricks AutoML is a unique glass-box approach to AutoML that empowers data teams without taking away control. Our customers love this approach to AutoML, and Casey will walk you through this new product later. But let's jump into the feature store first. All right, I'm extremely excited to talk to you about our feature store. Our feature store is the first feature store that has been co-designed with the data and MLOps platform, which provides several differentiated features. Let's start by talking about what we mean by a feature. Let's use a recommendation system as an example. Your raw data may look something like this: a user table that has attributes of registered users, an items table that stores information about the items you're selling, and a purchases table that has a record of all of the items that users bought. Where you want to get to is a list of items ranked by the likelihood of a user purchasing them. So how do we get there? Well, with a machine learning model, of course. The inputs to a machine learning model are referred to as features, and the output is the prediction. What features can we think of? The most basic features are simple transformations. Let's say you have a product category, and you want to encode that category as an integer when you feed it into the model. Context features are features that change with the context of where the prediction is made. That can be something as simple as the day of the week, or what device that user is using when they access your product. And in some cases, you may want to augment your data. One popular example is weather. You could access another data source to give you the weather in your user's location, which may help predict their purchasing behavior. And finally, a very common set of features that are used for recommendation systems are time window aggregates, like the number of purchases a user has made in different time periods. As you may imagine, some of these features, like a simple transformation, can be done by the model directly and don't require a feature store. But others, like time windowed aggregates, need to be pre-computed, stored in a feature store, and made available to the deployed model. So let's motivate the need for feature stores with a representative walkthrough of how data teams solve these challenges today. We start with raw data sources. The first time features are implemented is usually in an experimental setting. Data scientists often take the most expedient path, like copying code from Stack Overflow, to transform the data into the right features. Once data scientists found a model that works, it needs to be productionized. However, most often than not, the featureization code they wrote during experimentation doesn't quite work for a production setting. So the features are then re-implemented, sometimes by data engineering teams, to scale to the full data set. Now, if there's only one person working on one model, this may still be okay. But in big enterprises with large data teams, there is often another model that needs to be trained that consumes the same features. And because typically features are not easily discoverable and reusable, this whole process is repeated, even if the features are almost identical. This is the first big problem that feature stores address: no reuse of features. And once models are finally trained on the full production dataset, they're ready to be deployed. However, in order for the client application to make a valid request to the model, it needs to apply the same featureization that was applied at training time. Because that needs to happen within tens of milliseconds, the featureization is usually re-implemented once again, this time by the team that owns the client application. And these transformations need to be equivalent. Otherwise, you get something we call online-offline skew, where the model performs poorly because the online model behaves differently than the model that was trained offline, which is the second problem that feature stores address: online-offline skew and the complexity of avoiding it. So let's see how we can fix this. The first simplification that we will make is to only implement any given feature once. The feature store provides a feature registry that keeps track of all features that have been created and facilitates reuse across different models. We found that that alone saves multiple months of productivity in big data teams. Next, the feature store supports 2 access patterns that provide consistent versions of the features. The first is batch, for high throughput at training and batch inference. Model training can happen directly from the feature store. Because we co-designed the feature store with Delta Lake, it inherits all of its benefits. Most importantly, the data in the feature store is stored in an open format and can be accessed through native APIs. The same features are then made available at low latency for online serving. This guarantees that the features passed to the model from the client are the same as the features used in training time. Now, this already removes the need for re-implementing featurization in the client, because the features can be accessed directly from the feature store. And this is how most feature stores work. The client requests features from the feature store and then sends them to the model. But it still leaves complexity in the client. Like, for example, the client still needs to make sure that the versions of the features it requests are compatible with the versions of the model it calls. Because we co-designed the feature store with MLFlow, when a model gets trained using the feature store, we store the information about which features it consumes with the model itself. As a result, in serving, the model can deal with the full complexity of looking up the right features from the feature store, and the client can be completely oblivious to the fact that the feature store exists in the first place. Now, this is important. As a result, features can be updated without any changes to the client, significantly simplifying the deployment process. So in summary, the Databricks feature store solves these 2 major problems through a feature registry that facilitates discoverability and reusability of features. Because we integrate with Delta and MLFlow, we can provide upstream and downstream lineage. And a feature provider that gives consistent access to features at batch and online, and significantly simplifies the deployment process by packaging up feature lookup with the MLFlow model itself. So let's see how that works. To add features to the feature store, you simply decorate the function that computes your features and call create feature table. Once features are registered, the feature store UI provides an overview of all feature tables. One thing I like to highlight here is automated data source tracking, which logs all data sources that were used in computing a specific feature table. With that information, you can search the UI by data source, which enables a key workflow for reusability. When a data scientist starts the work, they can search for all of the feature tables that have already been computed based on the same data. And on the feature details page, you can see the downstream lineage. The feature store records all of the consumers of features and provides a reference to them. This is critical when updating features or deciding whether you can deprecate a feature table or not. And of course, putting together upstream and downstream lineage, you can go from raw data to features that were computed on those data to the models that were trained using those features and back. From there, you can create training datasets directly from the feature store. This API takes care of joining of multiple feature tables based on the primary and foreign key relationships that are stored in the feature registry. And to access features online, all you have to do is to publish them to an online store. Note that there is no code example here of how to look up features from the client, because you don't have to. The model itself knows how to look up features, so the client stays unchanged. We are very excited to launch the Databricks feature store, and starting today, it is available in public preview to all Databricks customers. Of course, some of our customers had already early access and saw great benefits from using the feature store. ABN AMRO is a Dutch bank that uses Databricks to fight financial fraud. The feature store has been of great help to facilitate reuse of features and accelerate their model development. And with this, I'll hand it over to Casey, who will walk you through the second new component we're announcing today, AutoML.
Thanks, Clemens. Let's take a splash with AutoML. As Clemens mentioned earlier, we're very excited to announce Databricks AutoML is now in public preview. AutoML is a powerful tool that automates the machine learning development process from dataset to tuned model. This automation enables data scientists to quickly validate a machine learning project's feasibility, as well as get a baseline model to help guide the project's direction. In addition to solving these challenges, Databricks AutoML also addresses problems that we see in current AutoML solutions. In data teams, we always find a diverse set of people whose familiarity with AI is on a spectrum. On one end of the spectrum are experts, people with PhDs in AI. They know exactly what they are doing and they want full control. You can think of this as they want 3 pedals and a manual gearbox. On the next level are engineers, who may not have PhDs in AI, but they still want control. And they want the most tedious things taken care of for them. So they want something akin to automatic transmission. And at the other extreme are what we call citizen data scientists. And they have this expectation for full automation. But just like with autonomous cars, most solutions for citizen data scientists just don't quite work yet in AutoML. If you reach their limits and there's no way to take over control, all you can do is open the door and get out. And that's what we've seen with many of these citizen data science solutions in AutoML today. That's why we're excited to announce Databricks AutoML. Our approach is to augment rather than replace the data scientist by providing a low-code, automated solution where data scientists can take control and drive with their domain expertise at any time. Like most solutions, Databricks AutoML provides a UI interface as well as an API that takes a dataset and performs data preprocessing, feature engineering and selection, model training and tuning, and ultimately returns a recommended baseline model for deployment. Yet, unlike most solutions, we use CodeGen to enable data scientists to see exactly what is happening under the hood and provide them with the source code for each trial run in separate, modifiable Python notebooks. The transparency of our glass box approach makes it so, 1, you don't have to spend time reverse engineering an opaque model in order to make customizations using your domain expertise. And 2, if for regulatory reasons you need to show your work, you have the Python notebook that you can share to explain exactly how your model was trained. Furthermore, we integrate with all the Databricks ML features and ecosystem. For example, all AutoML experiments are linked with MLFlow, so they track all of the different parameters, metrics, artifacts, and models associated with every trial run so that you can easily compare your models and easily deploy through batch or online inference. And with that, we're looking forward to you all using Databricks AutoML to improve your team's productivity with these reproducible trial notebooks that give you that source code so that you can immediately modify these models and use your domain expertise to get a production-ready model. Now, let's go see all these different Databricks machine learning features in action in a demo.
Here we are inside of Databricks. To build a model to predict crypto mining for our security team, I need to make sure I'm using the new Databricks machine learning experience. Switching to this is going to change my left-hand side navigation to show me machine learning tools and features that are relevant to my day-to-day workflow. Because I'm unfamiliar with the security team's dataset for predicting Dogecoin mining, I'm going to use the new Databricks AutoML tool to jumpstart my development by having it generate a baseline model for me. Databricks AutoML is going to take a dataset and do all the pre-processing, feature engineering, model training, and tuning for me, and provide me with the source code for a baseline model for me to iterate on. So without further ado, let's start an AutoML experiment. On this page, the first thing I need to do is select a cluster. The next thing I need to do is select my problem type. Because I'm trying to identify whether or not someone is a crypto miner or is not a crypto miner, this is going to be a classification problem. I next need to find my security team's dataset, which here it is in usage logs. And from here, I can see a nice overview of this dataset schema, which is nice for me because I'm not really familiar with it, so it's a good refresher to see. A quick glance through, I can see that is mining is going to be my target, which means I can come down here and say that is mining is the feature that we're trying to predict. The last thing I want to do is check out advanced configuration. One of my top goals is to give the security team a quick yes/no answer on whether or not their dataset can be used to predict crypto miners. I'm going to use this timeout option in the advanced configuration to have a predictable runtime for my AutoML training so that I know I can get back to the security team within a day with an answer. Setting my timeout to 60 minutes means that AutoML will return the best model it can within that time frame. I'm going to leave it at this 1 hour and go ahead and click continue. With my basic configuration set up, I can now choose to augment my dataset with more features using the new Databricks Feature Store. Feature stores allow our team to share existing features between different ML projects. So rather than me having to spend time to create all these new features when I'm on a time crunch, I can instead utilize the features already created by my teammates. For example, this account features table is managed by my customer success team and has features relevant to a user's account. Because Databricks Machine Learning is a data native platform built on top of a lakehouse architecture, it can intelligently suggest features I may want to join with to improve my training performance. As I said earlier, this is the customer success team's feature table, but it seems like it has relevant features to identifying a crypto miner, so I'm going to go ahead and accept this suggestion. I can explore and discover other feature tables in this dropdown, which my eye is caught on the IP feature table, which contains features related to the IP address, which again seems extremely relevant to identifying crypto miners. So we're going to go ahead and join on this. The only thing I have to do is I'll make sure that my primary keys are aligned. Before we start AutoML, there's one last thing to note. For this Dogecoin project, I'm going to be using both the offline and online feature stores. The Databricks feature store is going to help ensure consistency between these offline features that I'm using right now in training and these same features in the online store when I'm doing real-time inference, so that the model behaves as predicted without any training or inference skew. And with that, let's now start AutoML training. Now that an hour has passed and AutoML has completed, I'm going to land on a page that looks like this. Because AutoML integrates with the Databricks machine learning experience, you can see that MLFlow has been used to track all the models, parameters, and metrics associated with every trial run. This makes it extremely easy to compare each trial run and use my domain expertise to evaluate which model I want to use or iterate on for production. The other thing to note in this table is that it's sorted by the F1 score of the validation set, which is exactly what we said our evaluation metric was for AutoML. So the best model is at the top. Now, before I get too much into the weeds of comparing and evaluating these different trial runs, I was pretty unfamiliar with this security team's data set. So I kind of want to double check that this data set was fit for training. An easy way to do this is with the AutoML Data Exploration Notebook. AutoML provides a data exploration notebook to help me gut check my data and get quick insights. Much of this code is tedious to write, so data scientists like me may be tempted to skip this step to get to the more exciting part of building a model. Here you can see the Pandas profiler is being used to give me some basic summary stats. I can also see what warnings are associated with my data set. So here it just looks like some features have high cardinality, which for these specific features, it makes sense. And I can also see the distribution of my various variables. The main one I'm interested in is because I'm doing classification, I want to see if I have class imbalance. So I'm going to scroll to the bottom to my target. And sure enough, I can see that it looks like my classes are almost perfectly balanced. So I'm not worried about that. The last thing I want to check is my correlation matrix. If I come down here, I can see that in general, it looks good. It looks like event time might be correlated to my is mining target variable, but that kind of makes sense because we do think more and more mining activity is happening as people are really hoping to get to the moon. So now that I've used the data exploration notebook to gut check my data set, and I feel pretty confident that it was good enough to use in machine learning, I want to go ahead and register my baseline model to quickly build out an end-to-end proof of concept with real-time inference to see if I really can predict miners in real time. To do this, I'm going to go back to my experiment page, and I'm going to click this Register Best Model button. Here, I can create a new model to be tracked and managed inside the Databricks model registry. We're going to call this Crypto Detection. The Databricks Model Registry is a collaborative hub where teams can share ML models, integrate with governance workflows, and serve their models and real-time inference. On this model version page, I'm going to go ahead and promote this baseline model to the production stage. This is going to allow me to use real-time serving with it. We're going to go ahead and say baseline for proof of concept and transition it to production. Now that it's in production, I can go to my main model page. I can go to the serving tab, and I can click in one button to enable serving. Serving is going to create a REST API endpoint so that I can call this endpoint from any app and get live predictions using this model. Now that my endpoint is live, we can test it out directly inside of Databricks. One of the cool things about AutoML is that it's helping me adopt best practices with MLFlow. One of those things is to log an input example. Input examples are samples of your data set that you can then test your predictions on. So you can see here, I have some sample data that I can now feed in as a request, send it as a request, and get live predictions on whether or not someone's a crypto miner or not. Now, remember how we use the offline feature store to get features for training? Well, because we're in this data native environment, the model knows which offline features were used in training, and since that same model is being used in online scoring, it can automatically grab those same features from the online feature store for inference without me having to write any code. And to see further proof of this, you can come down to my logs, and I can see that sure enough, when I made this real-time call, the online feature store was used, and it grabbed features from my account features table and my IP features table. Great. So this is now the end-to-end of me building a proof of concept using a baseline model that I generated with AutoML. But I'm certain I can improve upon this best model using my domain expertise. And this is where the real power of Databricks AutoML comes in. If I navigate back to my experiment, one of the things that you'll notice here is this source column. In this source column, there are reproducible trial notebooks for every single trial run. And these notebooks contain the source code that trained that model. So you can see exactly how data is loaded, how one-hot encoding is done. You can see exactly how it was trained, which hyperparameters were used. And there's even a SHAP plot, so you can see which features were most important. Now, I have a hunch that crypto miners are probably newer accounts on the platform, especially since we've been seeing more and more mining-related activity happening. So I'm going to derive a new feature called member recency in the model that calculates how much time has passed between a new account being created and a user finding an event on the platform. To do this, I'm just going to insert a new cell. I'm going to write my code that creates this new feature member recency. And then I'm just going to make sure when I go to my pipeline here that I've added this feature. And I should be good to go. All I need to do now is click run all, and it's going to run all this training code for me. And I will have the next version of my model that is now using my domain expertise. And I didn't have to reverse engineer anything. I could just make direct edits to the source code notebook to iterate on it and get a better model. All right, now that training completed, let's go check out how we did. So if we come up here, we can see that sure enough, our F1 score did perform better. So now we're at 95%, and our log loss seemed to have improved as well. So now that we've improved using our domain expertise, let's go ahead and register this version of the model. We can use this handy code snippet here. We can say we're registering it to our crypto detection existing model, and we can just run this snippet to create version 2 of our model in the model registry. Now that this is completed, I can go on over to the model registry. I can click on my crypto detection, and you can see here that I have my second version of the model. Now, because this model performed better, I want this one to be the model that's live for real-time inference. So we're going to go ahead and promote this to the production stage. And now, when I go to my crypto detection model, and I go to my serving tab, you'll see that version 2 is now the one that's in production. And once the endpoint goes live, I'll be able to test it. All right, now that our endpoint is live and pointing to our version 2 of the model, we can do what we did earlier, where we're going to show our input example that was automatically tracked for us with AutoML. We can see that now we have the member recency derived feature in here. We can send this request to test our live endpoint, and sure enough, here we're getting better predictions. And again, just to end on that, our online feature store was being used on our behalf automatically using the Databricks feature store to ensure that we don't have any offline online skew. And that's how we were able to use Databricks machine learning to allow me to quickly vet my security team's data set so I could give them an answer on whether or not I could use machine learning to predict minors. And the AutoML reproducible trial notebooks allowed me to get a production-ready model in less than a day for my security team.
The Databricks machine learning platform allowed me to build a machine learning model that could predict crypto miners in real time to help my security team identify the suspicious activity. We were able to do this in a data-native way where all my data was in one location and I didn't have to pull it from various sources. We were able to do it in a collaborative way where I was able to work with my security team in Databricks to make sure that I had the right domain knowledge to build this model. And we did it from the whole ML lifecycle, from data set to deployment, all within a single location. And that's what the real power of Databricks ML is. Thank you all for joining us. And with that, I'm going to pass it off to Clemens.
Thank you, Casey. Very excited about these announcements. But wait, there's one more thing. You may be wondering how you get access to Databricks machine learning. We took all of these features, packaged them up nicely, and put a bow on it. As a unified platform, Databricks serves all members of a data team. So we're introducing a brand new persona-based navigation to Databricks so that each member of a data team has the right tools at their fingertips. Users can switch between data science and engineering and SQL analytics, and this is also where you will find the new machine learning experience. Of course, for those multi-talented among you, you can freely switch between options throughout your workflow. When you switch to machine learning, we surface the new machine learning capabilities and resources to you, including the new experiments page, the feature store UI, and the model registry. Some of our customers have gotten early access to all of these capabilities, and I'm happy to share their experiences so that you don't just have to take my word for it. Edmunds is a popular car shopping website that uses Databricks machine learning, among other things, for pricing vehicles on their website. Wildlife, one of the largest mobile gaming companies in the world, is using Databricks machine learning to personalize their user experience, which drives their top line. And H&M, the global fashion retailer, is using Databricks machine learning to parallelize model training for all of their countries, articles, and time periods. As you can see, companies across all industries can drive meaningful change with this solution, and so can you. So I'm happy to announce that all of the capabilities you saw in this keynote are available to all Databricks customers starting today. Of course, this was a lot of material, so to learn more, please check out our new website at databricks.com/ml. And with that, back to Ali.
Thank you, Matej, Clemens, and Casey. Now, it's my great pleasure to welcome Patrick Baginski, Senior Director of Data Science, and Abni Bhatt, Director of Data Analytics for McDonald's. McDonald's has been investing deeply in data and AI, and I'm very excited to hear how the Lakehouse is helping them advance their goals with machine learning.
Thank you, Ali, for having us. Welcome, everybody. My name is Patrick Baginski. I'm the Senior Director of Data Science for McDonald's, and I'm joined here today by my colleague, Abhi Bhatt, Director of Data and Analytics, and particularly interested in the machine learning operations field. We're going to be speaking today a little bit about our journey in the ML operations and data science space, and some of the choices we've made with regards to technology and architecture. But before I dive right into these topics, I wanted to provide a little bit of an overview for those of you who don't know us, which I hope are fairly little. We're essentially in about 119 markets in the world. So that means we have over 4,000 users of our internal machine learning operations related solutions. We're informing with those solutions about 39,000 restaurants, and ultimately generating about 65 million transactions every day, which means our Delta Lake is actually well over 1,000 terabytes of data strong. 2020 has really shown corporations and the economy the effect of societal and environmental impacts. And that's why I believe the QSR industry is actually no longer in the age of transformation. That's why I believe we're now in the age of acceleration. QSR, by the way, stands for Quick Service Restaurant Industry, of which McDonald's is a part too. And the way that McDonald's focuses on the importance of accelerating the value from data analytics is by focusing on what we call the 3 Ds, our most strategic topics. The first one is digital. So that means our application, our website, and other digital properties. The second one is the delivery business, both with our partners, Uber Eats, Seamless, and others, as well as with Mac Delivery, our own delivery service. And then lastly, the drive-through experience, in which we're also building data analytics solutions. And so based on that, now is really the time for us to essentially rapidly develop data analytics functions. And how we're doing this is we actually started with a small team about 2 years ago of only 5 to 10 people, engineers, data scientists, analysts. But now we have grown to actually over 45 people. And we started using open source technologies in order to deliver value from data science solutions. Now at McDonald's, we are in a hybrid cloud environment because markets operate slightly differently from each other. So that means that each market can have a different choice of cloud. And that's also why we invested in open source and other technologies that make it easiest for us to manage, deploy, and build data science solutions. And the reason why we're doing this is actually ultimately to really accelerate the time to value across our operations. And when I say time to value, what I mean by that is the time it takes for a data scientist to launch an experiment, prove value from that experiment, and then also move it into production with the help of my colleague Abi Bad, who is leading our ML operations team. Some of those examples of what we're working on is, for example, store forecasting, fine-grained SKU level forecasting. We're building recommender systems. We're working on drive-through automation, and then a lot of typical marketing-related topics such as customer lifetime value, churn reduction, segmentation, but also supply chain, restaurant operations, and food safety topic. And with that, I'm now going to hand it off to Abi, who will speak to you in more detail about our ML operations.
Thanks, Patrick. Hello, everyone. My name is Abi Bad, and I'm the Global Director for Data and Analytics at McDonald's. I'm excited to talk about machine learning and Databricks' journey at McDonald's with you today. In 2020, we went through a platform or a tool selection for our data science and machine learning users. And clearly, Databricks was our top choice. We selected Databricks based on a few key reasons. They are, one, Databricks it has a really easy deployment model where I can take the software and I can deploy it in my own cloud platform and keep the data and the infrastructure secured. So that enables us to do all of the data science workloads and setup and keep the data and the infrastructure and the platform secured. Second, Databricks as a platform provides the flexibility to the end users to bring the language of their choice. They could do their work in Python, Spark, or PySpark, or even just basic SQL. So depending upon the maturity of the user, the platform can address different languages and make it easy for them to adopt or come to the platform. Third, I truly look at Databricks as an integrated lakehouse platform with capabilities such as Delta Lake, MLFlow, and Databricks SQL, which makes it really easy to build models and scale them. So as you can see from the visuals shown, we bring in a variety of data into the Databricks platform. We bring in data such as our store transactions, our mobile app data for loyalty, customer marketing data, and also look at some third-party or open source data as well to bring in. And as within the platform, then the data science folks build a variety of different models such as lifetime value of the customer, product recommendation, demand forecasting, etc. These models then get consumed by either a front-end application, which the end users can call and have and interactively call the models. Or it could be as simple as the model output gets written into something, like into a table and gets consumed through a report or a dashboard in Tableau. So with that, I truly believe that with Databricks as the technology and the partner, we are on the right track of our MLOps and data science journey. Let's talk a little bit more about MLOps, as that's going to be our key focus for 2021 and is a hot topic in the industry right now. I truly believe that building data science models is hard, but scaling and operationalizing them is even harder at a global scale of ours at McDonald's. So here's how we are thinking about it. It all starts for us on how do we bring the data into the platform. The way we do it is we bring in all the data into an S3 bucket where Delta Lake is enabled. As you folks may know, Delta Lake is a storage format that helps us do data versioning and also build scalable and performant feature engineering pipelines in the platform. Next, we look at version control of our code. Today we use a combination of Git and repos, as repos will extend and make it really easy to manage code directly from the Databricks workspace itself. Next, once the models are built, the data scientist folks go through model experimentation. And this is done through MLFlow Experiment, which enables tracking of model parameters, evaluation matrix, such as accuracy, recalls, or precision, and we log model artifacts for each run. Next, as we have selected the final model and are ready for deployment, this is where, again, using MLFlow Registry, we manage the lifecycle of the model to go from staging to production or to archive, and essentially gets the model ready for serving. So when we go to model serving, we think about this in two patterns. One is on-demand batch scoring, and the second is an hourly inference using SageMaker endpoints. Now, we are also exploring Databricks serving capabilities, which are just coming up, and are excited to see how that also can help us streamline model serving through this platform. Now, once the model is served, we want to make sure that we are catching the drift or measuring the quality of the model as well. In this case, we are using a combination of SageMaker monitoring capabilities, which are very generic for measuring the quality of the model, and also for building custom KPIs using Pycart within the Databricks platform itself. So overall, how all of this comes together, I truly believe that this is a best-in-class solution for MLOps put in place using Databricks, MLFlow, as well as Delta Lake, and even AWS SageMaker. Next, let's see what the numbers tell us. As we talked about, we started our MLOps journey in 2020, but within less than 9 months, we have gone from 0 to production scale of MLOps, of scaling of the models. And within this 9 months, or less than 9 months, we've not only identified the tool, the technology, done the legal paperwork, which can always be a hassle, but also identified use cases, built the models, and deployed them. We've enabled more than 15 use cases with 30 plus models deployed in 5 plus countries or markets in which we operate. Multiple ML deployment frameworks have been built for the data science and the end users to ensure that we have the right security in place for building and deploying models. We built CI/CD pipelines, especially for deploying the models, and we will continue to enhance these frameworks. As you can see from a platform usage perspective, we have used about 130,000 DBU units, which is Databricks units, which is great for Databricks. And from a compute perspective, we are about 27,000 compute hours on a monthly basis in AWS. And while these numbers may look impressive, they are not for a scale of McDonald's. We anticipate that in 2021 and beyond, these numbers are exponentially going to grow at least by 4 to 5 times. And that will be when we are truly at scale doing MLOps at McDonald's. Next, let us share a little bit of our findings from our journey in data science and machine learning. And truly, the first point I would like to hit upon is that this is truly a journey for us of continuous improvement as well as learning. There's always going to be new data sources, new models, or enhancements that have to be in place, or skill sets that are needed. So always think about it as a continuous improvement journey. Next, identify the right technology and the tool set so that it provides it provides flexibility to your end users to either bring in a custom model of their choice or even do basic SQL-like stuff in the platform, right? And I think that's kind of what has helped us a lot to go with Databricks in that direction. Third, if you are building a new team or want to retain your team, it takes time to find and get new resources. So make sure you have a good hiring plan, as well as if you're a consultant-friendly company, ensure that your team is supplemented by consultants. And when you look at the skill set of your team, it's not just the data science folks or the data engineering folks. ML engineers and engineering is very critical as you go and scale your models or think about MLOps. So don't forget about those resources and skill sets. And last but not the least, in this case, I would call out is on the platform capabilities and technology changes. They are changing really rapidly. So being agile is critical, not just in your thinking, but also in ensuring that is the architecture and the solutions that you have in place so that you're always able to stay up and stay ahead of the curve and provide the best solutions and platforms to your teams. So if you look at folks, we have talked about why we selected Databricks, how are we thinking about MLOps, and kind of shared our findings. And as I mentioned before, this is truly a journey, and the journey continues for us. And for this part, I will hand it over to Patrick, who will take us on where do we go next, and what this part of the journey looks like for us. So, thank you.
Thank you, Abhi, for the deep dive on machine learning operations. Now, our journey truly does continue, as Abhi mentioned. And so I hate to use buzzwords, but one thing we're truly trying to do is continue to democratize machine learning and data science practices across the company using largely out-of-the-box capabilities and builds, right? And as a consequence of that, we also want to continue educating and providing learning opportunities to our teams, to the markets, to the different people that are part of the McDonald's system. We want to enable more end-to-end automation and machine learning operations in general. And so I spend about 1 hour to 2 hours every week talking to startups and new ideas to find out what is the best path forward, particularly when it comes to machine learning operations. And we want to continue to implement governance and also cost control measures in order to make sure that what we're doing from a business perspective continues to make sense. And last but not least, very importantly, we want to continue to learn and actually have fun along the way too. So what does that really mean for us at McDonald's? So we have a bit of a value acceleration roadmap now that we have the Databricks platform as a tool in our box. These are just 3 that I'm mentioning here. I talked about it before already. We're going to do some very fine-grained SKU level forecasting for our restaurants. We're going to continue to try to automate marketing and personalization related activities beyond just good machine learning for marketing, but actually using some unsupervised and potentially even reinforcement learning techniques in order to further automate the end-to-end interaction with customers through offers. And lastly, if you're doing this, you also want to have the cross-channel measurement and cross-channel performance measurement done right. And even the ability to be able to measure across markets, restaurants, and marketing efforts, how we are essentially performing with our marketing offers. And before I wrap up here, first of all, thank you everybody for joining the talk. I do want to mention briefly, our teams are still hiring at McDonald's. So you should be able to find a couple open job postings via my LinkedIn profile and the McDonald's career page. And with that being said, I'll hand it back over to you, Ali.
Thank you, Abhi and Patrick. Really, really fascinating work. Next, we have a great talk from Rajat Monga, the co-creator of TensorFlow, on how AI is eating all of software.
Hello, everyone. I'm Rajat Monga and here to talk a bit about AI. So this here is a deep neural network, something you've probably heard a lot about, especially if you're here today. So this one, as you can see, it has all these different layers where it's taking inputs, learning each layer, sort of applies a function to that and goes through all the way, makes a prediction, learns from that. And this is really one of the core algorithms behind what we see as the success of AI over the last decade. In addition to these algorithms, there are a few other things that have come together to make this possible. Here's one example. So, many of you may have heard of ImageNet. This is basically a data set with millions of images across lots of different classes that have been trained on to really improve the state of the art on many of the vision models that we have today. So that's sort of number two, putting the data together. In fact, data has sort of become so important here that you'll see things like this. If you are, hopefully you're not stopping a car and getting the stop sign wrong while they're actually running their stuff. But data is really, making a big difference in how far or how fast AI is making a progress in. So the third piece of these, once you have the algorithms and the data together, is how fast can you train these models on all the data set that we are creating here? And that's where the computational power comes in. What you see here is a TPU pod. It's actually a generation older than where we are today. But this is already 100+ petaflops with lots and lots of memory. And you can see a pretty amazing supercomputer. It would probably be, just based on this, one of the fastest supercomputers in the world at this time. So, that's the third thing. This is the computational power that we've seen coming together. And in fact, as these three things come together, that's really, changed the name of the game with AI and being helped with tools like TensorFlow. And I was, glad to be a part of the team that, built this and drove this for a while. So it was really exciting to see the change or the impact that this has been making. Now let's go back a bit over the last decade to see what's happened during this time. If you kind of squint on this, you'll see something that looks like a cat. And the reason is we learned from a lot of YouTube videos. And of course, who hasn't seen a YouTube video with a cat? So lots of good stuff, scaled on tons of machines, 16,000 CPU cores back in 2011. And that allowed our network to really learn to recognize cats automatically without telling it what a cat was, what a dog was, and so on. So that was pretty cool about this one. Now, as we go along, around the same time in 2012, as deep learning was taking off, folks over in Toronto, some students along with Professor Hinton basically came together and tried, okay, can you run this new kind of, not really new kind of model, but these kind of models, can you scale them up and run them on really large data sets like ImageNet? Before that, people were really programming and coming up with very custom features to build things like this. So when they did this, they showed a huge improvement on anything before. And this really started to change the game on how people were thinking about deep learning at this time. Over the next year or so at Google, we were applying this in lots of different areas, building new kinds of models. This is what came to be known as GoogleNet. Again, applying similar kind of ideas with convolutional nets, scaling across lots of different machines. And what this led to, what all these improvements in different things really led to improvements in products themselves. So if any of you have heard about Picasa, which was almost like a precursor to Google Photos a while back. That was a piece of software where you could really organize your pictures and you could manage them and you could label them yourself. You could put, saying, oh, these are pictures from my last family vacation and so on. So you could organize things like that. What Google Photos did was, you know what, all that organization that you had to do manually is now gone. You can just get things because you can search for them. It understands what the images are. It understands what the pictures that you're taking are. And that's really, changed the game in terms of all kinds of photo processing or image processing things that we were doing then. Of course, when you're searching for pictures, why type it out when you can speak it out? And so that was another area where we're seeing lots of advances around the same time. In this case, again, using the same technology, deep neural networks, that's been the underpinning of a lot of this, we saw where moving from the old style methods, which were also, somewhat learned, but somewhat programmed, to these fully trained networks allowed us to do like huge improvements, more than 20% error rate improvements over what was possible in the past. And what that changed was from being a research topic or being used in like very, very specific places, speech recognition became mainstream, where we can now, talk to our phones and do all kinds of things. You probably have a Google Assistant or an Alexa or Siri somewhere that you've used before. Of course, that was step one. Since then, there've been, lots more improvements. The next one was this new kind of architecture, LSTMs, that was applied to speech around that time, and that included that led to another 10% improvement on top of that. And we've continued to see those huge advances since then. Now, of course, when you think about speech, the part of the speech recognition is just to convert, okay, what you're saying to text, but you also need to understand that text. And that's where, over the last several years, we've seen a lot more advances in natural language processing as well. Started sort of with the BERT style of models and transformers, where this research led to, again, huge improvements in what could be done with natural language. And again, in this case, the data and the compute was as important. So the data set, there was a Q&A data set that came out of Stanford, and people started to optimize things and really learn from that. That led to some of these. And for folks, those of you who've been sort of involved in this area or have looked at this area, of course, more recently, there's GPT-3 that has shown even more advances as well. Of course, let's see where people are using this. What can we do with this? And so one great example is Google search itself. You may be familiar with the PageRank kind of algorithm. That's one of the first algorithms that really started Google. That's what Google was based on when it started out. Since then, there have been lots of changes and additions. A lot of them manual, a lot of them, just programmed in terms of combining different kinds of rules together to get better results in search itself. As you can see, this example really shows how just an advancement in terms of applying an algorithm like this, like BERT, deploying that in search, went from just matching the basic keywords, which was okay, but it wasn't really getting the context of what the user wanted. And the one on the right really shows how once it gets the context, it can really answer those so much, much better. Of course, these are not the only areas. We often think about all of these running in deep learning and other algorithms being very, very expensive. So they run in huge servers on the data center. That's often true. But with recent advances, it's been possible to really bring them down and run them on really small devices, including your phones. So in fact, very likely whatever phone you have, if you've bought it in the last few years, it's running some kind of deep learning models. In fact, this example here shows a model being applied to really get a better picture after you've taken it. And some of this can be done with your camera that's integrated on like Pixel phones, for example, where it blurs the background, combining not just your lenses, but also a whole bunch of smartness in terms of figuring out what's the foreground from the background as well. And on the phone itself, given that now we can get things in that small form factor, there's so much more that can be done. For example, here, there are places where you can't always hear the audio, or maybe you have trouble hearing audio, and being able to live caption things like that automatically just on your device without worrying about anything else just makes a huge difference. So thinking about, there's a lot of consumer stuff that we've talked about and phones. Of course, to show you the right things, the right applications that you want to use, companies like Google, you do a lot of machine learning behind the scenes to recommend the right pieces. And there's a lot of stuff that goes on here as well. In this case, there was a recommender system that really took information about the user, all the different things that could be recommended, and decided, okay, what should be recommended to this user when he or she comes on next. And in this case, we saw, what, this is great. There's a lot of stuff that goes on to put all those pieces together. And this was deployed, was doing great. But then when people started looking at what's happening, they realized, one of the big differences was what was being run or trained on in the data center was different from what was eventually being run and executed to make the recommendations. And just fixing that one thing led to a huge improvement, that 2% improvement in this particular case. And so, as you think about how all these pieces come together and they're made possible, there's a lot of different pieces that really need to be done for making this possible. There's so many different things to make this model work, not just get all the compute and the algorithm together. And so these are some of the pieces that you see right here. In fact, there are tools around TensorFlow that have been built to really solve for this. That whole ecosystem called TensorFlow Extended, with all these different pieces that all the way from validating data, ingesting it, processing it, building the models, deploying in production, and really to help folks take care of that. And that's really to help bring AI into more and more things across the board. So we're clearly seeing lots of advances in this, and we're seeing lots of applications of that as well. Of course, not all is great with AI, and so there are a number of issues with AI as well, and wanted to just talk about a couple just to make sure we're mindful of it when we think about AI and do things at our end. So one, for example, with as they say, with great power comes great responsibility. There's a lot of power in terms of, say, identifying faces and doing recognition and so on. But that can be used in all kinds of ways and not always in a good way. If you think about cameras all over the world, most cities today have cameras deployed in different places, whether it's in the eastern side or in the west. There are so many different cameras that can be used in different kinds of ways to recognize people and do different kinds of things. We need to be really responsible and thoughtful in how we want to use them as well.
We're entering an era in which our enemies can make it look like anyone is saying anything at any point in time, even if they would never say those things. So, for instance, they could have me say things like, Killmonger was right, or Ben Carson is in the sunken place, or, how about this, simply, President Trump is a total and complete dipshit. Now, you see, I would never say these things, at least not in a public address, but someone else would. Someone like Jordan Peele. This is a dangerous time. Moving forward, we need to be more vigilant with what we trust from the internet. It's a time when we need to rely on trusted news sources. It may sound basic, but how we move forward in the age of information is going to be the difference between whether we survive or whether we become some kind of fucked up dystopia. Thank you, and stay woke, bitches.
So as you saw here, there's this opportunity to change things or how they look. And over the last several years, we've been talking about fake news in lots of different contexts. And the ability to really make things look so real has never been possible before now. This just makes that problem harder, and we have to be really careful about how we use this technology in good ways as well. So talking about issues, those are some of the issues that AI is bringing. But in broadly, stepping back, there are lots of different challenges that humanity faces as a whole today. I'll talk about one of them, energy. If you think about how much energy we use, here's a number here, 1 million terajoules. One way to think about it is, let's think of energy required to boil a single kettle of water. Now think of 8 billion people boiling that kettle of water every single minute, round the clock, all the time. That's really how much energy we are using every single day. And today, that's really coming from lots of fossil fuels, really, hurting us in lots of ways, of course, with climate change and the heat that's causing. All's not bad, and that this is one area where perhaps AI can help. There are lots of renewable areas, renewable energy sources that we are working on, solar and wind being one. And from simple things like just looking at, okay, how can we repair these windmills? How can we find the turbines and the problems with them sooner, to forecasting the solar and the wind power sooner and much better, allows us to make a lot more progress and allows us to use these more effectively and efficiently towards a much better future. And so really what I want to end with is AI is really making a difference, and it has a huge possibility for impact. Thank you.
Thank you so much, Rajat. So exciting to see what's happening with TensorFlow. I hope you enjoyed and learned a lot from today's talks. I'm really excited about the integration of Qualys into Spark to make data science scale much easier. The adoption of MLFlow is really impressive. It's great to see the work that the community keeps putting into the project. Great new features in Databricks ML with AutoML and Feature Store. It is now my pleasure to introduce our next guest speaker. Bill Nye is popularly known as Bill Nye the Science Guy. He's an American mechanical engineer, science communicator, and television presenter. Following the success of his show, Nye continued to advocate for science, becoming the CEO of the Planetary Society and helping develop sundials for the Mars Exploration Rover missions. Please join me in welcoming Bill Nye to Data and AI Summit.
Greetings, Bill Nye here. Hello to everybody at the Data and AI Summit. It's great to see you all again. Wait, I can't see you, but you can see me. And that's good because we're using millions and millions. I would say certainly 10 million, but probably closer to 1 billion transistors to engage in transistor logic and have this fabulous interaction. So thank you all for including me. Now, for those unfamiliar with this kind of picture, this is a picture of the Earth, and it's where I've spent my whole life, down there someplace. And I just like to remind people, it's not out of focus. That's the Earth's atmosphere. And the atmosphere is extraordinarily thin. In many pictures from space, the atmosphere is so thin. How thin is it? You can't even see it. It looks, as the old saying goes, it's like a coating of varnish on a globe. But I spent a lot of time in the atmosphere and breathing it and carrying on. And my first job out of engineering school was at Boeing. And I worked on 747 airplanes. Don't worry, everybody, if you've ever been on a 747, I was very well supervised. It's a fantastic plane. You're very safe on a 747. All right, with that said, when I was there, there was a guy who was still around, who was a test pilot on the very first 707. In those days, it wasn't even called the 707 yet. That was a designation that came along later. That was the Dash 80. This one is when they first painted it, this picture when they first painted it. And you don't have to know too much about airplanes. Can you see there's two features about it that are cool. Do you see how long, how wide the wing is at the root, as it's called, of the wing? In those days, that was all that structure was needed to hold the nacelles, the engines. And then you see all those vanes, those are on there to create to promote the turbulent boundary layer, to make the air flowing over the wing do this, the molecules tumble, and it actually reduces drag in exactly the same way you reduce drag by putting dimples in golf balls. And so I spent a lot of time there, and there was a guy who was still around, who was the test pilot, whose name was Tex Johnston. And Tex Johnston, like many guys of that era, he had been a pilot in World War II. He affected this US accent that Chuck Yeager, the famous guy here in the States who broke the sound barrier in a rocket plane, the X-1. And Tex Johnston was a test pilot on this airliner. And he did a barrel roll with the airliner. He took this giant plane and rolled it over twice. And there's this famous picture taken by the flight engineer. This is back in the day when an airplane like that would have three people in the cockpit. Well, in those days, they were all men in the cockpit, a pilot, co-pilot, what we now call first officer, captain and first officer, and then a flight engineer. And the flight engineer took this picture. This is the guy that would watch the fuel gauges and make sure they weren't messing up. But it's upside down. So Tex Johnston lands. And this is before mobile phones at every press conference and video of everything that ever happened. You know, this is a different era. But by all accounts, Boeing management says to Tex Johnston, I paraphrase, but you know, Tex, what are you doing? This is our prototype. This is the only, you know, be careful with this thing. He said, I'm selling airplanes. And then he's supposed to have said, one test is worth 1,000 expert opinions. And those are words to live by, my friends. One test is worth 1,000 expert opinions. You can't beat it. That you can claim you know what's going to happen, but to really find out what's going to happen is of tremendous value. And let me say, I am honored to be invited to speak at the Data and AI Summit, because you guys and gals are the future. You all are going to change the world. You all are going to respect the facts and make the world better than it is today. And so I really appreciate you including me. Now, I know many of you are not in the US and may not be familiar with my work, but I'm a mechanical engineer. I worked on this gizmo to suppress vibrations in the yoke, the steering wheel of the 747. That was cool. It's the kind of thing they give to a young guy. All right, when you're fresh out of school, you can still do this arcane sort of off in the corner math. And so that was cool. I had tremendous loyalty to Boeing for a long time. But when I was in college, people were just beginning to talk about, or university, people were just beginning to talk about climate change. And climate change, you could say these days, was discovered on Venus, the planet Venus, when James Hansen, who's still around and testified in front of the US Congress in 1988 about climate change, pointed out that the Venus is kept warm by carbon dioxide in the air, in the Venusian air. And it's happening here on Earth because humans are putting extra carbon dioxide in the air, not just in the air, but putting it in the air fast, extremely fast. And that's the problem. And then when I was in school, this famous astronomer, Carl Sagan, and another guy, Jim Pollock, had done this analysis that if you set off all the nuclear weapons in the world at the same time, you'd create this huge dust cloud that would shade the Earth for weeks and weeks or months and months. And then Walter and Luis Alvarez found the crater that almost certainly it was a result of the impact, which created a dust cloud so big. How big was it? Bigger than the Earth's diameter, that it finished off the ancient dinosaurs. They may have been, the ancient dinosaurs may have been having trouble with other atmospheric problems, but that impact is what did them in. Anyway, these three things came together for me in the 1980s and then in the 1990s. And I got very concerned about climate change. I got very concerned about science education. I got very concerned about engineering. And so you guys, I'm so old. How old are you? I'm so old. When I was in school, we had punch cards. When I worked at Sunstrand Data Control after Boeing on black boxes, which really are black to radiate heat, we had Fortran 7. Woo! Oh. Anyway, a lot has changed in the last few years, but the principles of data management and computing are the same, just that you all are able to have the machine learn from its mistakes in a way that we just could not do. So my awareness of climate change has been with me for decades. And just recently, entities that concern themselves with these problems, National Aeronautics and Space Administration here in the US, the Intergovernmental Panel on Climate Change at the United Nations and elsewhere, have realized that this year is almost, or it's tied for the hottest year on record. The hottest year on record was 2016, which was a hot year combined with an El Nino. And El Nino is this warming of the Pacific Ocean that its effects are well known, but its cause is still a mystery. Anyway, in the El Nino year, it was the hottest year on record. 2020 was almost exactly the same hotness, overall warmth, but without an El Nino. So the world's getting warmer and warmer, faster and faster. That's where you all come in. You are going to, dare I say it, change the world. And you're going to do it by doing more with less. So for those of you around the world who may or may not have heard of this thing, I claim there are 3 things you want to do for everybody on Earth. You want to provide clean water, renewably produced, reliable electricity, and access to the internet for everybody in the world. And in order to do that, when people talk about clean energy, we're talking about electricity. You know, electricity is magical. You can do amazing things when you have access to electricity. And so you can make toast for your breakfast, or you can have a conference like this, electronically engaging people all over the world. And so along this line, there's an organization here in the States and that works with people around the world called the Solutions Project. And they have done an analysis. And look, you guys, I'm not saying this analysis is perfect, but it's something to think about. They have done an analysis, starting with the United States, that you could provide clean energy to everybody in the US right now if you just decided to do it. You would have geothermal energy where possible, wind energy, solar energy, not shut down any existing nuclear power plants. But don't try to build any more because it takes too long to get them done. And you use a lot of concrete, and there's no place, nobody wants the waste. Even if you had a great idea of what to do with the waste, nobody wants it. And they have continued the analysis. They say that we'd get about almost 3 million jobs just to run all this new infrastructure. And, you know, infrastructure is a big word right now in the US. But they claim you could do it around the world. Now, let's say they're off by a factor of 2 or 3. This would be a huge start. If we had 100% clean energy around the world, we would solve an enormous number of problems for a great many people. And everybody, the whole idea that this can't be done is, to me, is misguided. It just looks like it can be done from an engineering standpoint. Geothermal, wind, solar, new, better battery storage, and perhaps in the next 15 years even, or let's say 20 years, we will have something like fusion energy. And of course, it will come to the developed world first. There will be problems with it. But in the next 40 or 50 years, it's very reasonable for a change that could be doable. If that's possible, we could, dare I say it, change the world. And so along this line, there's something that's very important, that's even a bigger idea than clean water, renewable electricity, access to the internet. And that is raising the standard of living of women and girls. When you raise the standard of living of women and girls, everybody's life is better. Everybody's life is improved. When you have twice as many educated people in the world, you solve problems in new ways. Study after study has shown that the more diverse the team you have trying to solve a problem, the faster you get to a more satisfactory or better answer. So you guys, maybe you heard that that's a truck outside the window because we're doing this electronically because we couldn't get together in Northern California in the US this year. There it goes. Carry on, you guys. Anyway, we're able to do this because you all have created this remarkable technology. Now, raising the standard of living of women and girls is not an easy task. If you know where to look, the family myth is that my great-grandmother is in this picture. This is in the United States, in Washington, D.C. I grew up in the city of Washington, D.C., in the city limits. And the family myth is that my great-grandmother, Sally, was a suffragist marching in this parade the same week, I guess 3 days or 2 days after her first grandchild had been born. And, and a lot of people, a lot of grandmothers get very engaged with grandchildren, but no, she was out marching in the suffragist parade. And that was, you guys, well over 100 years ago. Now that family myth was passed down to me, but I can tell you this for reals as an eyewitness. My mother marched in the Equal Rights Amendment parade here in the United States, where women wanted the rights to vote. And my friends, of course, these are citizens of the country, and so they should have the right to vote. And just for those of you into the details, the Equal Rights Amendment was brought up, especially in 1973 is when it really got going. And there's a rule here, law here in the United States. If there's 50 states, 38 of them or 2/3 of them have to agree to it. Well, the Commonwealth of Virginia has agreed or ratified the Equal Rights Amendment, and it's number 38, but there's all these issues of, has it expired? Has it been there too long before enough states ratified it? Anyway, all that aside, the world is changing. Whether or not this Equal Rights Amendment here in the world's influential, technologically, nominally sophisticated society, the world's third most populous nation, whether or not that happens this year or next year, it will certainly happen in the coming decades. For me, in my part, I would like to happen this weekend, but it'll happen sooner or later. The world is changing, and that's exciting. The world's getting warmer and extraordinarily fast. Women are being empowered in a way they have not been in millennia. And we are all going to have to get used to changing. And that is your business. That's what you all are into. The future is open. You all build software, and now combinations of software and machines that learn from their experiences electronically, automatically, softwareically. And so you all are the future. And I very much hope you will take this responsibility very seriously so that you can change the world. Now, speaking of which, the same guy who co-wrote this computer program in 1980, Carl Sagan, through a remarkable series of happenstances, was my college professor for one class. And he started the Planetary Society. 1980, we are the world's largest non-governmental space interest organization, advancing space science and exploration so that people everywhere know the cosmos and our place within it. Then the elevator door closes. No, that's you. The Planetary Society, through another extraordinary set of happenstances. Not only did I take one course from this guy and join as a charter member in 1980, now I'm the CEO of the Planetary Society, and we work to get governments and people around the world to support space science and exploration, especially the exploration of planets. So you guys, we are living at this extraordinary time. The Perseverance rover just landed on Mars, and it's got 2 microphones on it. And I've been in meetings, you all, where I won't say with whom I was in these meetings, where people, oh, we don't need to put microphones on Mars. No, we know the composition of the Martian atmosphere. We know exactly what it sounds like. You don't even need to do that. That's a waste of time, waste of weight on the spacecraft. And, it's a waste of bandwidth for telemetry, sending information back to, you don't need to do that. Okay, we put those microphones on there. And last week, the Ingenuity rotorcraft, this helicopter, the tips of the blades go at about 0.6 Mach A 747 can get up easily up to that speed. But on this in this extraordinarily thin atmosphere, this other world, and these scientists saw the dust move on the surface of Mars in a completely unexpected way, and they heard the sounds for the first time. And I claim the Planetary Society was instrumental, pun intended, on putting those instruments on Mars. We got a microphone on Mars in 1999, Mars Polar Lander, but it became Mars Polar Crasher when these retro rockets didn't fire with a software problem. The landing gear extended, the software thought, if I can use that expression, thought it'd hit the surface, but no, it was in mid-space and just barreled in. Anyway, Carl Sagan and the Planetary Society have changed my life. When you look at this image, it is a way of addressing these two questions we all ask. We all ask these questions. Where did we all come from? And are we alone in the cosmos? If you want to answer those questions, you have to explore space and you have to explore Mars. So those layers of the Kodiak Mesa, which is the tentative name for this feature on Mars, are sedimentary layers under a cap rock. That's how a mesa forms. This place used to be soaking wet. There used to be a gigantic body of water flowing through here. Are there fossilized microbes in those layers, what on Earth we call stromatolites? And in the background there, you guys, that's not like dust in the atmosphere. That's the wall of the Jezero crater. This enormous feature on Mars that may have signs of life because it was the delta of some ancient body or of water or river system on Mars. And you all will very likely be alive when this discovery is verified or set aside. This hypothesis is embraced or set aside. If we found evidence of life on another world, it would change this one. It would change the way every one of us feels about being a living thing in the cosmos. And I claim there's a great lesson to be learned from this. The exploration of planets is a metaphor or a way of thinking about exploration in general. If you stop looking up and out, what does that say about you? Whatever it is, it's not good. So that's why we advocate for the exploration of other planets, not just here in the United States. We are an international organization, 100 members in 130 countries around the world. Check us out. Carl Sagan in class also told us this story back in the disco era. Johann Kepler was looking at the night sky and he observed what the comet that nowadays we refer to as Comet Halley. You may have used the expression Halley's Comet. That's fine, but they found people from the Halley family. They prefer to say Halley. And now the astronomical tradition is to say Comet blank, Comet Halley. Kepler was looking at this thing and he realized there's something about sunlight that was creating these tails. There's the dust tail and the ion tail, these charged particles that stream behind a comet as the dirty snowball, as it's called, gets volatilized by sunlight. So he speculated in 1607, 400 years ago, that he said people will sail the cosmos the way we sail on the ocean. And indeed, Carl Sagan presented this idea to this very famous talk show host here in the United States, Johnny Carson, back in 1976, September of 1976. We'll build a spacecraft so big and shiny. How big and shiny would it be that sunlight would just push it through space without any mass exchange? In other words, it's not the solar wind, it's not the particles that will push this thing. It's photons, pure energy, no mass. And this has been speculated about since Kepler's time, verified in the 1920s, really, when relativity was discovered and the quantum was investigated. And he proposed this, he and his colleagues proposed this spacecraft to catch up with Comet Halley to be launched in 1980, catch it in 1986. Well, it didn't get built. The space station and International Space Station and the US Space Shuttle program superseded. And the Ariane, the rockets, the European rockets and Japanese rockets, they were built in exchange for this mission. All right. The Planetary Society pursued this for years. We built the Cosmos 1 solar sail. It ended up in the Barents Sea, which is an area, if you're savvy about global ocean going navigation, it's part of the Arctic Ocean. It's an area. It just crashed. All right, well, 5 years ago, the planetary side managed to build LightSail 1. I was on a very famous talk show here in the United States, The Late Show with Stephen Colbert, a guy who succeeded essentially Johnny Carson after decades, talking about our solar sail mission, which is absolutely derived from Carl Sagan and his colleagues' mission and Johann Kepler. And we got it to work, you guys. LightSail 2 is flying right now. LightSail 2, you can check us out at planetary.org and see where it is. And we proved that if you all are the sun and the microphone is the earth, we could come at you like this, twist in space, get a push, twist, get a push, and build orbital energy, even in the gravity environment near the earth, where making this maneuver is hard because of the inertia of this large spacecraft. For those of you who remember anything about your fundamental physics, I know you're all software guys, but it's still true. Physics is still, as we say, things happen for a reason. That reason's usually physics. All right. We built the spacecraft to prove this for space agencies around the world and private and public space explorers, space exploring corporations, because this technology might enable us to take cargo to Mars for free. There's no rocket fuel kind of thing. So that was the intent. And along with that, we built these cameras in the spacecraft that are very high quality. They're made by a company here in the States called the Aerospace Corporation. And it took our engineers, men and women who are here in California mostly, but also at Georgia Tech. Georgia is a state in the US, and there's some people that work now and then when they have time in a community college in Hawaii. And they have messed with the software over the last 2 years, and they're able to get these extraordinary pictures. This was the launch. It was a LightSail, it was a Falcon Heavy, a SpaceX Falcon Heavy. And, you know, that company is very pridefully led by this famous guy here in the States, Elon Musk. And they used boosters that had already been flown. They strapped them onto this thing, and they had 3 of these giant boosters, 27 engines. Your chest shakes, your hair shakes. Oh man, it was just amazing. And so we got the thing in orbit, and the software people over the last 2 years have been able to send down these fantastic pictures. And this is what astronauts of all nationalities refer to as the overview effect. When you see the Earth from space, it changes the way you feel about the Earth, and it changes the way you feel about living on the Earth. And you guys, what's happened over the last millennia, 100,000 years, instead of humans being controlled by nature, or what you might think of as everything not human. Now humans, we are in charge of nature. We are running the show. This is the Nile River and a bit of the Suez Canal from our spacecraft. It changes the way you feel about being a living thing. Are we alone? Where did we come from? Where did we come from? Well, now we're running the Earth. We're in charge, and that's where you all are going to change the world. The key to the future is not to do less. It's not to not drive, not eat, not wash your clothes. The key to the future is doing more with less. And that's where software and machine learning and artificial intelligence, to me, are going to change the world. Now, here's a famous picture taken by the Cassini spacecraft. Cassini was a mathematician who predicted or showed where the gaps in the rings of Saturn would be. And he was right. And this picture was taken a few years ago, and it's amazing. There's Saturn. It's gorgeous. The sunlight coming from the south pole of Saturn. What we've learned about the weather on Saturn has affected or influenced our analysis of climate change here on Earth. And speaking of the Earth, this is not just a beautiful picture of Saturn. It's a picture of the Earth. For those of you unfamiliar with this, the Earth's right here. That's it. That's the whole thing. That's everybody. If we fly up here this way about 100,000 kilometers, there's the same picture. And Saturn's would now be below us if we were in a spacecraft taking this picture. Do you see the Earth? It's right here. That's the Earth. That's everyone you've ever met. That's every fungus. It's every tree. It's every sea jelly. Carl Sagan was very eloquent about this too. You know, every emperor, everyone who tried to control a corner of this dot in space, they all lived here. They've all come and gone here. There's nobody coming to save us. If we mess up the environment to the point where many of us cannot have a quality of life that's suitable for carrying on our generations of people, it's our fault. This is it. This is where we make our stand. This is the Earth. This is our home. This is where artificial intelligence and the future being open to new ideas, this is where you all are going to, dare I say it, change the world. Thank you all very much for including me in this conference. You guys now, guys and gals, get out there and change the world for the better. Clean water, renewable electricity, access to the internet to raise the standard of living of women and girls as we run the show here on Earth and make it better for everyone. Thank you.
So this concludes our second day morning keynotes. Thank you all for tuning in. We have really exciting keynotes and sessions in the afternoon. On behalf of all Databricks, thank you for tuning in.